You guys are always asking me, when am I ever going to use this stuff? When is this stuff ever coming up in real life? So here's a real life situation for you, okay? And it starts off with something that's really possible. You're really, really wealthy. Do you know how I know you're really, really wealthy? You know how I know? Because you own a lumber company. See, it says your lumber company. So all of you own lumber companies. Congratulations.
Yeah.
You're making the paper that helps us learn. Okay, so you have a forest with 1.2 million trees, and you plan to harvest 7% of the trees each year. How many years will it take you to harvest half your trees? Now, what's a simple way to approach this problem? A simple but wrong way to approach this problem.
To find what 7% of 1, 2, 0, 0, 0, 0 is.
1 million.
Yeah, that, and then that, and then divided by 100. Or divided by.
I don't know, that sounds very complicated.
Oh, really?
Alright, first of all, how many trees are we going to have when we're done? Alex?
No, you remember that you asked the other one?
No, I want you to answer my question. How many trees are we going to have when we're done? Which is what? You're not Alex. Give Alex a chance, please.
7%.
No. Remember, percent is not a number. You don't end up with 7% of something, an actual number of something. Lucas, can you help him out, please? You don't know if you can help him out. If I start with 1.2 million, I end up with half of that amount. How many trees do I have left? There you go. So that's our goal. We want to know, how long is it going to take us to get 600,000 trees? The simple way would be, okay, I'm cutting down 7% of my trees per year. How many years will it take me to get to 50%? 7% of a year times how many years is 49%? Oops.
Wait, what?
How many years at 7% a year will it take me to get to 49 years?
Oh,
7. Now, what's the fallacy in that? Does anybody know what a fallacy is?
Yeah.
False.
What's wrong with that? What are we talking about here? No, what thing?
Sustainable.
What are we talking about?
Trees.
Trees. And what's the nice thing about trees?
They sustain.
What does that mean? What does that mean? Not that they grow back, but what can you do? And what else can you do? You can plant new ones. Thank you. So we're not dealing with a situation where we're simply cutting down a percent of trees. We are cutting down a percent of trees, but what's happening? We're putting back some of the trees. So we need to find a different way to do this. And that's why we are going to ask ourselves this first question. Is an exponential model reasonable?
Yes.
Rachel, is an exponential model reasonable here? Why? Besides the fact that it says modeling with an exponential equation? No. But I said we're not doing it that way, remember? That's right. That's right. It's not accurate. We need something more accurate. Now, let me take a little side trip. Okay? Either your parents, or one day you, or let's go back to the beginning of the chapter, and we were depositing money in the bank. What did it tell us about the interest rate? What was increasing? The money was increasing, but what about the interest rate? The interest rate stayed the same. It was a fixed rate, and Does anybody know when we might see fixed rates of something besides putting your money in the bank? How many of you live in sales tax? Good. Sales tax is a fixed rate. No matter how much stuff you buy, you pay a certain percent. Very good. Those are what I was speaking of, but yes. Any of you live in a home? No, not that kind of home. House. What do your parents pay each month?
Right.
Guys,
Rent if you don't have a home. Or they're renting a home. Buy a home, I should have said.
Okay.
They pay a mortgage. When you go to the bank to take out a mortgage, you can pay a fixed rate or an adjustable rate. Fixed rate, bank says you will pay us 5% per year, and that amount doesn't change. The adjustable rate, the amount changes depending on the time period of the loan. There's different lengths of time of adjustable rates, 1 year, 2 year, 3 year, 5 year, and that's a discussion for another day. We'll talk finance another day. But if you have a fixed rate, and that's what we talked about, you put your money in the bank at a fixed rate, we can use an exponential model. So this each year, that's the key. If the question says 7% each year, the answer is yes, because the percent is fixed. Okay, now, either you know the answer to the next question or you have notes that will tell you the answer to the next question. What equation do we use for exponential models? Raise your hand if you think you know the answer. See, it's blank. If you don't know this, you need to have this in your notes. Nicole.
Isn't that A equals A1 plus R? Yeah.
1 plus R what?
T.
T.
What?
Yes. It's actually step 2. Gerard, you notice I put Nikki's formula and another one on the board? These are the two formulas that we use to calculate interest.
what is that? The next one in parentheses to the right.
This,
No, the little thing over there.
that's a T.
Oh, I think.
Yes.
Think.
Which one is right? And why?
Go.
How do you know which one to use? We learned 2 of them. How do you know which one to use? What do your notes say?
I would use it.
Why? It looks easier. So next time you're arrested and you're on trial and the prosecutor says, he's guilty because he looks guilty. Are you okay with that? Why not? That's exactly what you just said. He looks guilty, so let's put him away. What's wrong with that kind of thinking, Lucas?
I think the easier route.
You said because it looks better. But what's wrong with that way of thinking?
Could be wrong.
Well, of course it could be wrong. What aren't you doing? What do you have to do in court to win your case? You have to listen?
Think about it.
What do you have to do in court to win a court case?
I've never been in this.
You ever watch TV?
No.
You ever watch a movie? You ever seen a courtroom?
Evidence.
You have to do what?
Check your evidence, your work. Solve it. Okay.
The prosecutor has to prove that you committed the crime. The plaintiff has to prove that you hit him with your car. You gotta prove it. You can't just say, I'm gonna use this one. You'd have to demonstrate why. Now, why is this one wrong? Who knows why this one is wrong?
Because that's continuously.
Exactly. Where in this problem does it say you are? Yes, your tree cutter is working 24 hours a day, 7 days a week, cutting down the trees. Does it say that here?
No.
It doesn't say continuously, so you can't use the formula for continuous change, compounding.
So
Thank
you can use both of them? I mean, not both, for some, that kind of programs? Also, you're never going to use that
No,
one?
you can't.
No, we can't use
this. We can only, Alex, we can only use this one if it says compounded continuous.
No, but I mean, we can use that one, not one for.
No, you can't use the one that I crossed out at all in this type of problem. That's the point I'm trying to make. You have to use this one. Okay, now let's fill in some numbers. What's my initial amount? Okay, I'm gonna write it.
1.2.
I'm gonna write it down here. What's the R?
The rate.
And the T?
1.
How many years?
Timing.
7.
How many years?
One?
Do we know?
No.
It's what we're being asked to find.
Oh.
What's the problem with this?
Then you have to do a logarithm.
What's the problem with this?
You have to solve it.
What? What? What happens when you start? What happens when you multiply this? What kind of number do you get?
A really big number. Good job, Nikki.
Really big number.
That's not really.
You get a number bigger than what you started with. Is that a problem here? Why?
But it's
Too many numbers.
No, it's not a problem.
What? What are we doing to the trees?
Cutting them down.
We're cutting them down. So after the first year, are we going to have more trees than we started with? Or fewer? So then what do we have to do with this plus sign?
Change it to a negative.
Change it to a minus sign. Now, what does it equal? What's our goal? Remember, this tells us what our goal is. What's the final number of trees? 600,000.
Half that.
Not half that, half this.
Yeah.
Okay, now we can start solving. So the first thing I'm going to do is I want to get this by itself. So I'm going to divide both sides by 1,200,000. And we already know what is 600,000 divided by 1,200,000.
Two.
We just said what percent this is
It's
of
calculated.
this.
It's calculated.
Half. 0.5. And this, what's 1 minus 0.07?
53.
Point what? No.
No, 0.53.
If I have $1 and I spend 7 cents, how much do I have left?
93.
We're lost.
Now I'm going to convert this to logarithms. So I have the log of 0.5 is equal to the log of 0.93 to the t. I have used my power property, so I get the log of 0.5 is equal to t log of 0.93. What's the next step?
Divide by log.
Divide by log of 0.93. I plug this into my calculator. What I get is about 90.55. Now the question doesn't say how to round, so if you look at the calculator, do this in the calculator. No, it doesn't. Yeah. It gives you 955,134. If you don't know how much to round to, again, what did I say to do? Look at the largest, how many decimal places out. So that's 0.93 is 2 decimal places out. So if my answer is 9.55134, I'm going to, bless you, I'm going to round to 2 decimal places, 9.55. Okay, does anybody have any questions about this?